Some of us are new to EPMATH127. EPMATH127 was okay to jump in on halfway through. So I'm going to have a bad habit of keep saying, last semester. And I'll just apologise now as a gross apology to those that weren't here last semester. I don't mean to keep doing it. And you don't have to have done last semester. It's going to feel like a flow-on. Okay. So what's on the slide? The assumed knowledge. So whether you did last semester or not, in EPMATH126 in fundamental. So assuming fractions, not manually, not fractional algebra. We've got calculators, okay? But just so you know what fractions are, the basic concept. Same with decimals and percentages. Not calculator free, just we've got the concept. We know a 0.5 is a half, it's 50% of something, that sort of thing. Basic algebra, I'll give you some examples in a sec. I really just mean very basic algebra. Again, not fractional, as in the big ones like we had in the mid-semester, just simple algebra. Basic equation solving and basic units. I don't mean all the mega and giga and stuff like that. Again, we'll get to it. I just mean like the meters, as in milli, centi, meters and kilometers. That's it. Okay, so just the base stuff. And saying if in doubt, do the maths diagnostic quiz. If you're thinking, oh, I don't know, am I up on that stuff? Am I going to be okay for this semester? Well, we've got a diagnostic quiz, not the one on the first Blackboard page. That's for engineering maths. That's an undergrad thing, but we can all see it. So not that, but this one. We've got one in the New Step folder, the one that we've all got access to, New Step. And there's a quiz in there down here, Maths Diagnostic Quiz. It's just something I wrote with 14 questions. And it recommends if you get 12 or more, yep, you're right to go. 11 or less, either rethink or just know that, okay, there's a bit of catch-up. So it's not a have to, it's just if you're in doubt, and it's just got a few questions in there. Here's a few questions I've just chucked into this lecture, just of all I'm talking about, like how do I find 20% of a number? Now, again, your calculator will have a percent button in it, so I don't care what you call that. But do you times it by 20%, divide it by 20%, add or subtract 20%? It's a bit early for questions, but... Sorry? Yep, times it. That's A. So when you find a percent of something, it's like of as a times. Yep, I'm going to go to the calculator and find 20% of something. Yeah, it's times. Now, just to check this, 20%. So we know it's multiply. Which of them's right? Multiply it by 0.2, 20 on 100, 20%, or more than one of them? So. And look, I'd go A, I've got a calculator, A will do. Any of A, B or C will do. D won't work, but A, B and C, yep, 20% is 0.2. It is 20 on 100. It is 20 with a percent key. So it's all good. You got the calc. If Y equals K on X, here's a tiny bit of algebra. How do you rearrange that to K equals? Just look at the first one and say, I just want the K by itself. Exactly. If I want the K by itself, I want to get rid of that divided by X. I want to times by X. So it becomes K equals XY, YX, same thing. So that's what I mean by algebra knowledge. That. How do I find a third of a number? Again, even though you've got a calculator, you might be thinking times, divide, and you don't have to know all the options. But finding a third of a number, divide by 3 will do it. So B is a correct answer. There's another correct answer there. C, multiply it by a third. They're exactly the same thing. Dividing a number by 3 thirds it. Timesing it by a third thirds it. So they're both good answers. Yep. So that's what I'm getting at. Oh, okay, and how many millimetres are in a centimetre? I've got a cheat thing to put on your cheat sheet, a recommendation. But yeah, it's 10. So again, just into the milli, centimetres and kilometres. Sweet. The drop-ins start today. They're on every day. We've got the same room every day now, which is good. Oh, we had the same room. We didn't have the same time on Mondays. But anyway, yep, every day at 12 o'clock in LG42. Clearly I'm doing the lecture. There's only one lecture. Lucia and Peter are still with us. Maureen, we're reducing classes. There's only 7 shoots this semester. And unfortunately, we've lost Ben. He's not dead, but he has gone to Melbourne. I still hate him for it. but he's got some work. He's got 2 semesters of work at a primary school, so he's pretty chuffed. So, at a high school, sorry. He did casual work at a primary school. So what's in this semester? I won't spend long on this because, well, we'll find out. But we're still all allowed to change courses in the first 2 weeks. It's like first semester. And I'm hoping you don't want to jump out of this, but you might want to tell others to jump into it. But anyway, what are we going to be doing? Okay, today ratio and scale measurement. I don't think you'll find it too daunting. A bit of trig, only 1 week and only right-angled stuff, no sine rule, cosine rule, just basic trigonometry. Bit of apportionality, just about the number plane really, and a bit of real-life stuff. Can we settle again, please? Please. It sucks having 8 AM, it's catch-up time, but... Linear functions, you all probably have done y equals x plus b at some stage. We're going to call it something different, but it's going to be fairly straightforward. Logs could be foreign. Chances are it's foreign, but it's a well-liked topic. As soon as you start, people go, is that all it is? It's going to be one of those, is that all it is things. Exponential functions, a bit real life again, just like populations of rabbits, humans, same thing. Financial applications, that's really minimal. I hate financial applications of stuff, but it just feeds in with one formula, and it's just fairly applied, and it's just one formula for the whole topic. A bit of stats, just the basics that you've probably already covered in some things, but we're just going to look at what's relevant towards the uni direction. And a bit of probability, some simple, some a bit more complex in the last week, but yeah, some probability. This is for trivia's sake. I put it up at last week or the week before in the info session, just for people to say, look, I did EPMATH127 in Sem 1, what can I expect in Sem 2? Every dot there is some student looking at what they got in Sem 1 and then it got in Sem 2. So there's like this person in Sem 1 got 65, in Sem 2 got 30, okay? That person didn't like Sem 2. This person got 70-something in Sem 1 and then got maybe 88 in Sem 2. So everyone in the pink, red, see-through triangle did better. You can see it was pretty even, okay? People did a similar mark. What actually happened was the average in Sem 1 was 69, this is last year, in Sem 2 was 67. So there was a 2% drop on average, but it's very individual, you can see. Some people did heaps better, heaps worse. The other thing, the main factor, I reckon, attendance in Sem 2 went down to 61%. That was the average attendance that we recorded, from 79% in Sem 1 to 61. And that happens. I mean, I hope it doesn't, but it happens. Sem 2 attendance drops off and marks drop off. But that's up to you, okay? That's your call. People whose attendance was up, the marks are up, and it's just the way it is. Okay, so redemption. Now, for those who haven't done it before, the quiz mark redemption, when you get a quiz back, which isn't for a few weeks, you can do a redemption on it if you choose to. If you got 4 questions wrong, or 4 marks wrong out of the 10, so you got 6 out of 10, you get half of those 4 marks back. A lot of people in Sem 1 didn't do redemptions, and that's totally your call. But some people who did redemptions, it was the only reason they passed, be it through the actual marks or just gaining knowledge from it. But there's instructions on the redemption process on Blackboard. Again, it's optional, but it's really useful. Get half those marks back, turn 6 out of 10 into 8 out of 10, and just understand what went wrong. What else? Blackboard is full of stuff. It looks the same as last semester. Course outline, info book, stuff about the drop-ins. There's the mark redemption. There's one thing I have added. Oh, I'll get to it in a sec. There's the course information booklet. It contains... We've got a course outline as well. Everyone's got to have a course outline. The information booklet is basically the course outline in a more useful format and a lot more info. It just hopefully answers any question you got about what happens here, what happens there. It's in there, okay? What else? The course reader is $15. It's better than first semester. This is what they normally look like. They've got all the exercises in them as well. In first semester, I took them out trying to make it cheaper, and it made it $1.50 cheaper. It was a really dumb decision on my behalf. So I've undone that decision. Now it's $15 and it's quite thick with all exercises and answers, all just extra stuff, okay? We'll still give tutorial worksheets, but there's extra exercises in print in the book. So yeah, we definitely need that. It's got spaces for lecture examples, and it's not the same as last year's. We've made changes. Resource sheets for every assessment task. Doesn't have to look like that. In fact, it shouldn't look like that. That's a little bit over the top. Discussion board is there. Traditionally, we don't use much as discussion board, but it's there if you want it, okay? And just note there, you can press subscribe into any of these categories, either because you've posted or you want to know if others post, but it'll just send you an email if anyone posts. So just if you press subscribe, it'll just keep you up to date of what people are talking about on Blackboard. And if we start using it, it's pretty useful. And notice here, like study groups, if people want to try and find a study partner, just post there, or just general questions. I can't do that question 1E on that worksheet, and myself or someone else will jump in, because anyone else can answer any questions if you know. Anyway, discussion board. The structure is like this, same as Sem 1, but maybe new. So here's week 1, we discuss lecture A1. In the tute, we work on A1. The quiz on A1 will be next week. Then you'll get it handed back in the tute the week after, and then the redemption's due the week after that. So you've always got over a week to do a redemption. You can do the redemption at home, in the maths drop-ins, do whatever. But yeah, so there's a structure, and it's still the case that we've got 6 A lectures. They're in the mid-semester in week 8. Then the B lectures are after the mid-sem content. In week 8, we won't have tutes, we won't have a little quiz, we'll just have the mid-sem in here. Yeah, standard structure. In week 13, we won't have a lecture, but we will have those revision tutes. 11 quizzes, only 8 from 11 count again, so 3 quiz marks won't count. So that can mean either you just drop 3 of your worst marks, or if stuff happens and you miss 3 quizzes, well, it's not that important. You'll get there. Resource sheets mean that I said that in all assessment tasks, every quiz. So the quiz next week, quiz 1, yep, resource sheet, A4, front, back, handwritten, and calculators every week, every task. Okay, so there's a calculator. It doesn't matter what type of calculator you've got, as long as it's a scientific one. Any calculator you had at school would still be right. If you're looking to get a new one, those ones are fantastic. The FX82AE Plus or Plus 2. You don't have to get them, but they're pretty popular. Most people have them. And it's examinable, as in like the first quiz will have a couple of questions, which is just chuck this in your calculator. And as simple as it seems, like, well, you can't get it wrong if you chuck it in your calculator. Yeah, you can. All right, so let's just make sure that you're okay with your own calculator. Here's a demo video. It's very early to get that head stuck at you, but let's look at the demo video. This is a scientific calculator. This is a scientific calculator held the right way up.
Natural display calculators are very easy to use, but here's a few tips that might help. The fraction button is your friend. You can press the fraction button first, then put in the numerator and arrow down to the denominator. Or you can speed things up by putting in the numerator, then pressing the fraction button, and then just pressing the denominator. Mixed fractions? Pressing the shift button will give you all the functions shown in the yellow writing. So shift, then the fraction button will give you this. Now input your digits, arrow across, and then down. You can alternate between mixing in proper form by pressing shift and then the SD key. What's the SD key? The SD key converts between standard, which is fractions, and decimals. You'll be using this key a lot. The calculator stores the answer from the last time you pressed equals. Even after pressing your clear, the calculator remembers that there's a 2 in the memory. Want to raise a number to a power? 5 to the power of 2. Want pi? Shift, pi, equals. Want scientific notation?
Here's where we pause and discuss that, I don't know. Well, that's disappointing. So, okay, there's a 4th root key. You can press that. And be careful to arrow out of under your square root sign if you not, okay, this video sucked and bye. Well, glad it was just a demo. That's on Blackboard if you want to watch that again. So if you are getting a new calculator, there's the natural display ones. Definitely recommend them. because it's just, you see exactly what's on the paper, okay? The other calculators, of course they're totally fine, but you need to get used to using brackets, and they're just harder, okay? So if you're used to that style, great. If you're not used to that style, I would make the change to the natural displays, because it's just a lot easier. Okay. These, did I even bring one? Let's check. Because the demo worked so well, I did. I'll just go to visualize for a second. Oh, it's the wrong one. Has anyone got one of those normal calculators with them? Is that a natural? I'll just... Yeah, thank you. Woof. All right, again, not going to spend long on it. Just want to make those points that I was making before. Like, pressing the refraction button, great. And the question had root 5 plus 6 on it. But just note, if I just write root 5 plus 6, a lot of people do that. But if the square root sign was meant to have stopped, remember to come out of it by pushing the side of this replay button and then putting the plus 6. So just be careful where that square root sign stops or whether it keeps going. Arrow down, the denominator was just 7 plus 8 in this question. And of course we can see, yes, everything's right, all good. The other thing was mixed fractions, when I was saying, if I said I want to do a mixed fraction of 4 2/3, I think I'd press 4 and then the fraction button and then 2/3, and it doesn't work. It sucks the 4 into the fraction. So the mixed fractions, I've got to use this key here. Shift and then that yellow key gives me the mixed fraction setup. And now I do 4 2/3 by putting the 4 there, arrow across to the 2, arrow down to the 3. So mixed fractions are a bit slow to put into this calculator, but that's not too bad. By 3 2/5, so I'll do it again, 3 2/5. Rightio, they were the two main ones I just wanted to talk about. Oh, and the SD key. So S stands for standard form or fractions and D is decimal. These calculators normally push out a fractional answer. If you want as a decimal, just press the SD key. Okay, that's really all I really want to say about that one. Thanks, Chris. So that's the intro. We'll go back to PC. And this is just, once again, I'm referring to Sem 1. I'm not going back into how to do this stuff. It's just a bit of advice. It's for a lot of topics. I've just chosen decimals. Now, last semester, we don't have to remember it, but last semester we talked about when we multiply decimals, all I've got to do is count the decimal places and put them back. So there were 3 decimal places in the question, 1, 2, 3, and 3 in the answer. That was our method. And when we divided them, it was a different method. We said, well, put it as a fraction, times it by whatever makes it a whole number, and then do the division. Again, that knowledge is null and void. The method now is type it into your calculator, okay? The point I want to make is the majority of students use the first method for both of them. We had a different method, but not everyone. Most people use the first method for both. And the only reason I'm bringing this up is I'm saying I'll start making a resource sheet now. Because if your resource sheet just said, if it's times, ignore the decimal places and put them back, divide, write in fraction form, make the denominator whole. Any little notes that you tell yourself, and you just don't make that error. Because everyone who wasn't on the resource sheet and just started assuming, well, I'll just use the first method all the time. So my recommendation is, get the marks up there, just start a resource sheet now, put stuff in the margins, put stuff to the side, whatever, little pointers, okay? Don't need to write out the whole course notes, just little pointers that make sure you're using the right method for whatever. And it just helps heaps. Anyway, so on to ratio and scale measurement. Now, with the ratio topic, it's a little bit fractiony, but just the simple part of fractions. Let's get into it. Okay. So a ratio is something that compares the size of 2 quantities in the same units. As in A to B, some number to some other number. It tells you what ratio 2 things are in. Like a 5 kilo bag of cement and 10 kilo bag of sand, the ratio is cement to sand, 5 to 10. They're already in the same units. If they weren't in the same units, if it was 5 grams and 10 kilograms, I wouldn't just write 5 to 10, because 5 grams would be 0.005. But 5 to 10, Totally. 20 mils of cordial, 100 mils of water. Clearly the ratio of cordial to water is 20 to 100. All right, that's a ratio. But as you might have felt, they can be simplified down. That first ratio of 5 to 10 is saying for every 5 whatevers of cement, add 10 whatevers of sand, as long as they're the same whatevers. 5 buckets of cement, 10 buckets of sand, perfect. So all it's really saying is, well, how much cement you're putting in, put in twice the amount of sand. So we can simplify that ratio, like as if it was a fraction, 5/10. How many 5s are in 5? 1. How many 5s are in 10? 2. So 5/10 and 1 to 2 is exactly the same thing. It's just saying, I don't care how much cement you put in twice the amount of sand. If you put in 5, put in 10. If you put in 10, put in 20. Okay? So 5 to 10 is a ratio, 1 to 2 is the same ratio, just in simplest form. Same way as in fractions. 5/10 was acceptable, but it's exactly the same as a half. The 20 to 100, well, we can say, look for a common factor. How many 20s are in 20? Just one of them. How many 20s in 100? There's 5. So all that ratio is saying is, how much cordial you put in, put 5 times more water. Okay, so we can simplify ratios, and that's going to be the first exercise. Write this ratio in its simplest form. Here's just stating that it is, just like fractions. If someone wants me to simplify 32 to 60, well, I can think of it as 32 on 60 and just think whatever I did when I simplified fractions I can do here. I can try and find the largest common factor, or say stuff it and just halve the top, halve the bottom, divide the top by 3, divide the bottom by 3, whatever I can spot they've got in common. They're both even, I can halve it. It's a 16 on a 30. They're both even, I'll halve it again. It's an 8 on a 15. They're not both even, but I'll try and fish for something else that's in an 8 and in a 15. And I'm coming up dry. They've got 1s in them, but that doesn't help. They don't have 2s in common. The bottom's got 3, but not the 8. 8 on 15 is already in simplest form. All right, that's the answer. But of course, we don't have to write it like that. We're just saying, you know, halve it, halve it, halve it, halve it, and you get there. Okay, 8 to 15 was it in simplest form. So the first exercise is just like simplification of fractions. And we've got a calculator now that simplifies fractions. We'll get to that in a sec about the good and bad parts of using the calculator to do this. Mostly good. And then simplify, said that. So an example, a batch of mud cakes is made using a ratio of dirt to water of 1 to 4. What percentage of each mud cake is dirt? In this course I use Sheldon's head to say, slight trap, it is a bastard. You meant to say D, and then I meant to say you got it wrong, but you didn't. Okay, but can you see why D might be tempting? The answer D, because I think 1 to 4, that's a quarter. That's 25%. That's why Sheldon's looking there. But if it says what percentage of each mud cake, so if I look at comparing the amount of dirt to mud cake, the dirt to water is 1 to 4, but what's the amount of dirt to mud cake? For every 1 amount of dirt, how much mud cake is there? Well, if I put in 1 part of dirt and 4 parts of water, how many parts have I got in the mud cake? 5. So that's just saying that, just check the question. It wasn't asking for the ratio of dirt to water, it gave it to me, but dirt to mud cake was for every 1 part of dirt, there's 5 parts of mud cake. So, and if that sucks, just make up some units. Dirt to water was 1 to 4. In other words, if I use 1 kilogram of dirt, I'll use 4 kilograms of water. Just the brain often works better if we're talking actual amounts. So how much dirt is there for every mud cake? Well, there's 1 compared to 5 kilos of mud cake, because clearly I've just made 5 kilos of mud cake. Yes, it's a 1 to 5 ratio. And 1 to 5 is a fifth, that's 20%. Calculator will do that for us. Okay, so I went straight to a trap one there, but there's plenty of other examples coming. Other ways that we'll see it in words. Josh earns half as much as Tim. We've got a few more word questions. I won't say word problems because that makes you think they're traps, but word questions. But you can see if Josh earns half as much as Tim, clearly it's saying Tim earns more. I can write it a half to 1. For every half a dollar Josh earns, Tim earns $1. But in simplest form, I should define simplest forms. Simplest form has no units left in it. Okay, there's no dollars or units or anything there. Whole numbers only. So I don't want a 0.5 there. and the smallest numbers possible. So like if someone said, I've got a ratio of 6 to 24, I'd say there's no units, good. Their whole number's good. But I can make them smaller. I can divide both sides by 6. That's its simplest form. If someone said, I've got, well, this, 0.5 to 1, let's just times both sides by 2. If I times this side by 2, a half becomes 1, times this side by 2. Yeah, that's a way to make it happen. Another way I could have done it is said, well, I could times u by 10 and times u by 10. Well, it's still going to work. 0.5 times 10 will become 5. 1 times 10 will become 10. But I can simplify that. How many 5s are in that? 1. How many? Either way, I'm getting to 1 to 2. Whatever you can see that gets rid of decimals and fractions. Yep, perfect. The next one, we're starting with, in the Childcare Center, there are 4 staff for every 14 children. Clearly the order matters. I mean, I could have written this children to staff and then written 14 to 4. It's exactly the same thing. It depends what your first line is. I'm just saying it in order. But staff, there's no need to turn it upside down, back to front. 4 staff for 14 children, fine, 4 staff for 14 children. But I can go 2 to 7. It's a pretty simple simplification. Mary's car was 1/3 the cost of Jan's car. It's like the first question. Mary's car was 1/3 the cost of Jan's. Jan's was more expensive. So I can put 1/3 for Mary and 1 for Jan. But let's times by 3. Times the left by 3 makes it 1, times the right by 3. It's exactly the same statement. Mary's car was 1/3 the cost of Jan's. In other words, Jan's was 3 times the cost of Mary's. Same thing. The Australian dollar is worth 98 cents US. Well, the Australian dollar to the US dollar, the Australian dollar, as in $1, yep, is worth 98 cents US. That's all it's saying. And in this case, we don't want that decimal there, so we want to multiply it by something. The easiest way to turn this into a whole number is give it 2 moves of the decimal. In other words, just times it by 100. If whatever you do to the left is okay, if you do it to the right. So it becomes 100 to 98. That's close to simplified form. It'd be very tempting to say I've done it, but they're both even. We've got half both sides there. 10 to a 50 to a 49, that's simplest form now. All right, so again, we're getting to, well, doesn't the calculator do this for me? Yes, and it's acceptable. We'll get there. What about this one? Again, pretending we don't have the calculator at the moment. 2/3 is a ratio of 2/3 to 6. Now, firstly, I still want to use multiple choice against itself, like get rid of answers that just can't be true. Can you spot any answers that are not simplest form in the selection of answers? D? D for the correct answer or D for the... Why 1 to 3? Why don't you like 1 to 3? I mean, it's a whole number. What about anything that isn't simplified? Okay, so we've got to vote for A, for the good one. 2 to 6, what's wrong with 2 to 6 as a potential answer for any question? That's not simplified, that's 1 to 3. 2 to 18, that's 1 to 9. All I'm saying is those two can't be, they're not simplified. Get rid of them. It's a 50-50. Now, if we do look at 2/3 to 6, I'm thinking algebraically here, not for long, but I'm seeing that if I got 2/3 and wanted to get rid of that 3 on the bottom, I would times it by 3. That's totally acceptable to times it by 3, times both sides by 3. So yeah, I'm doing a little bit of algebra, but I'm just saying, look, if I do a 3 times here and a times 3 here, it'll become 2 to 18. Okay? And 2 to 18 is 1 to 9. So that was a good move. If I've got those fractions there, also a thing, those here last semester said, there was a case like this when that was an equals, and we said, look, that 3 can multiply up there, and that 1 can multiply up there. 1 by 2 is 2, 3 by 6 is 18. Yeah, that works as well. Okay? But so the easy thing is to get rid of a denominator, just multiply it by that number, but do it to both sides. So we ended up at the top. Yep, 1 to 9. What about that one? Since it's decimal form, I'll be thinking more karaoke, jump the dots. I want whole numbers, so I don't just want one jump. One jump will make that 3, but one jump, that's still 0.6. I want 2 jumps. If I give 0.32 jumps, as in times it by 100, it'll become 3, then 30. If I give 0.062 jumps, it'll become 0.6 and then 6. Now again, there's my trap answer. It says simplest form. Let's also look any others not simplest form. Well, it can't be A because that's the left is just half of it. No, it's not A. C can't be. That's looking pretty good. It's B. And let's just check it. How many 6s are in 6? 1. How many 6s are in 30? 5. Yep. But again, multiple choice, there were some answers that are like, nah, can't be you. All right. So here's the bit about calculators, which is fine, but just want to point out some traps. If you're asked to simplify 5 to 20, I hope most of us will say, look, it's 1 to 4. I don't need the calculator on here, but let's play with it anyway. We know the answer is 1 to 4. If I put 5 over 20 into a calculator, because I'm saying that all these ratios are like, it's like a fraction. 5 over 20 into a calculator, it'll tell me the answer is 0.25. That's not helpful. But if I press the SD key to convert to a fraction, it'll show me it's 1 to 4. That's correct. So, yeah, it still works. Hopefully 5 to 20 is 1 to 4 is still, it's okay for us ourselves, but the calculator, when we put the answer back in a fraction form, yeah, it is. What about 20 to 5? Sorry, Chris.
When you put it in the calculator, will it just be the 5 to 20, or is there a way to put it in that one as well?
Oh, no, there's no ratio key, there's no button to say, put it in 5, what's that called, a colon? 5 colon 20, no. We just got to know that, look, it's like fractions. Yeah. 20 to 5, if I put that in the calculator as 20 over 5, what's it going to spit out? 4. But what's 4 as a fraction? 4 over 1. So yeah, it will still give us the answer, but don't write down the number 4. 4 is not the answer. The answer is 4 to 1. Again, 2 ones that are easier and quicker to do ourselves in our head, but yeah, still works. What about 24 to 10? If I was doing it manually, I'd call that 12 to 5, and I'm done. But let's check this calculator will do it for me. 24 on 10 will give me a 2.4. That's not cool. But if I convert it, if I press the SD key, it'll show me 2 and 2/5. That's still not really helping me. But if I press the improper fraction key, it'll say it's 12 on 5. There it is. So if you can get the calculator to express it as an improper fraction, you're fine. I still reckon it's easier manual, but I'm not going to fight it. I'm going to discuss the calculator. 40 to 12, manually I'd call it 20 to 6 and then 10 to 3. Well, let's do the calc. It's 40 to 12. Calculator spits out a repeated answer and I'm going, ugh. But if I make it look like an improper fraction, there it is. Yep, 10 to 3. So as long as you make it look like a single fraction, as in improper, which is top heavy, or normal, which is bottom heavy, not a mixed fraction, just make it equals a number over a number, the calculator's done your work for you. 0.6 to 5.8. We can go straight to the calc. Normally I would call it 6 to 58, times both sides by 10, and then maybe halve both sides, and then say, I think I'm done. The calculator would spit out something horrid, but when I made it look like a fraction, it was 3 on 29. It worked. This fractional one, manually, I'll times the 7 over here to give 14, and I'll times the 3 over here to give 12, and then I'd halve it. But if you don't like it, the calculator spits out something horrid, turn it into an improper fraction. There it is, 7 to 6. Okay, so it's all good. So, some lecture examples. Simplify the following ratios. Now, first up, I don't want hours and minutes. I'm not calling that 1.25 to 20 because they're not expressed in the same units. We don't care what units you pick, as long as they're the same. And I've got the choice, well, I've got many choices. I could convert them both to hours or both to minutes, or something else, seconds if I wanted. I don't know why I would. But I'd always choose the smaller units. I wouldn't be wrong if I chose the bigger units. I'd say, well, that's 1.25 hours compared to 20 minutes is 20 out of 60, a third of an hour. But that's a bit Who wants that? Well, suppose I've got a calculator, who really cares? But personally, I would rather convert it to minutes. 1.25 hours also, that's not 1 hour and 25 minutes. Okay? Sometimes we write that. But 1.25 hours, how many minutes is it really? 1 hour and how many minutes? It's, yeah, here we've got the 60 minutes is the 1 hour, and 0.25 just means a quarter of an hour. What's a quarter of an hour? 15 minutes. So really, this question is compare 75 minutes to 20 minutes, and once I've got the same units, I don't need them anymore. Okay? It's just easier to convert to the smaller ones. That's what I'd recommend. 75 to 20, I could go to the calc, or I could say, oh, you both got fives in you. You've got 15 fives, and you've got 4 fives. Yeah, 15 to 4. We're done. Okay, and the next one, again, I've already said we can go to the calculator, but that manual thing where I said, well, that 3 can times up here to give a 9, and that 4 can times up 2 to give an 8. Is that simplified? 9 to 8? Nothing else we can do? 15 to 4 was right, 9 to 8 was right. All right, all good. That's simplification of ratios. Here's a first 3-part. Now, 3-part ratios are no different, as in we treat them the same, but the calculator doesn't help us. Those calculator shortcuts I had was for 2-part ratios, not 3-part ratios. We don't have a 3-part fraction button, okay? But that's not too bad. A bag of marbles has 35 red marbles, 21 green marbles, and 14 blue marbles. So first I write down the order I'm writing them in. 35 of the reds, 21 of the greens, and 14 of the blues. And then I just look for a common factor between all of them, which is not 2 and it's not 3. 7. 7's looking good. How many 7s? 7 5s. 7 to 21. 3's looking good. 17, 14. We're not getting any simpler than that. All right, so 5 to 3 to 2. So for every 5 reds, there's 3 greens and 2 blues. Perfect. So 3-part ratios, we're sort of forced to do them manually, but it's not that much of a shocker. The length of a rectangular room is 5.95 metres and the width is 3.5 metres. Express the dimensions as a ratio in simplest form. First I check the units, metres and metres, good. I don't need to do any converting. Now, it was given to me in the form of length to width. I could swap them, but again, why would I? Just leave it. So I'm talking about a length to width ratio. The length is 5.95. The width is 3.5. And to be honest, yeah, I'd go to the calculator with that. 5.95 over 3.5 and get it to give it to me as what would be, since the top's bigger, an improper fraction, and it would spit out the improper fraction in simplest form for me. But we'll just do it manually, just in case it was a 3-part one and I couldn't use the calculator. I know that I want 2 moves on that. I only need 1 there, but we do the same to both sides. So in other words, I'm going to times both sides by 100. 2 moves gives me 595. It's like all I'm doing is converting it to centimetres. That's 595 centimetres. 2 moves there, that's 350 centimetres. Yep, everything's still going well. 5 is definitely something I want to divide both sides by because I've got a 0 and a 5 they're ending in. If I divide the left by 5, I get 119. If I divide the right by 5, I get 70. And then I go, ugh, I wish I'd just used the calculator. Is that it? No? Should I spot something else? 9, 10, 11, 3s, 2s, 5s. Ooh, 7. Ooh. Divide that side by 7 and I get 17. Divide that side by 7 and I get 10. That's it now, isn't it? Good boy. All right, 17 to 10, I got myself whole numbers, but I admit I was about to stop there. The calculator is my friend. I should have checked it. Okay, so 17 to 10, simplest form. Good. What else you got for us? Okay, so I've not... Sorry, Chris.
On the calculator, if you press the fractions button twice, you get the
You get the...
You get a 3-level one, press it twice, and so on. Does that not work?
No, that'll just be doing that fraction divided by that fraction, which would be that fraction times. No, it's not going to work. Worth checking though. All right, so the ratio of that to that. First thing I check is I've got different units. And as I said, the only units we're going to continue to talk about are everyday units. The centis, the millis, the kilos. So 250 mils. Once again, I'm going to pick on the small units. I'm going to leave the 250 alone. What's 1.25 litres in mils? 1,250. And again, I've got this cheat sheet thing coming up soon, which might be useful on a memory aid. Yep. Okay, 250 to 1250 mils. I don't need the mils anymore. The largest common factor there, what I'm looking at is 250. How many 250s are in 250? How many 250s are in 1250? 5. 4 250s make the 1,000, and there's another one. But again, calculator's fine. But 1 to 5 ratio, 1 of them, 5 of them, perfect. Is 3/4 of a tonne of sand and 1 2/5 tonnes of soil a mix? What's the ratio of sand to soil? Okay, glad I used 2 S words. Sand, soil, 3/4 of a tonne, 1 2/5 tonne. All right, I don't care about the tonnes, they were the same. Good. And here again, if you did the fraction or 3/4 over 1 2/5, that will give you your correct answer. The calculator will do it for you. I'll just use a bit of last sem to say, well, that's the same as 1 2/5 was 7/5. And if I do that cross multiply thing, the 5 by 3 is a 15, and the 4 7s is a 28. Fish for something that goes into a 15 and a 28, and I'm coming up empty. So no 3s, no 7s, no 5, nope, 15 to 28. But I'm sure the calculator would have spat that straight out as a fraction of 15 on 28, and I was there. Okay. If the ratio of apples to oranges in a fruit bowl is 5 to 3, how many oranges are there? I don't know. So that's just checking the concept, that a ratio of 5 to 3 doesn't tell you how many things are in the bowl. It tells you for every 5 apples, there are 3 oranges. I don't know, maybe there were 10 apples and 6 oranges, 20 and 12. I don't know the answer. Ratio just tells you the proportion between the two, but not literally how many there are. It's like that ratio of 1 to 2 for the cement to sand. It doesn't mean there's 1 gram of cement and 2 grams of sand. Maybe 1 bucket, 2 buckets, whatever, okay? Just tells you the ratio. Other ways to analyse a ratio. A ratio of cement to sand of 1 to 2 means what I wrote in that picture there. It just means for every 1 part of cement, there's 2 equal parts of sand. So that picture tells a story. And these are just words that describe that picture. There's half as much cement is used compared to sand. Well, that's true. I only used 1 thing of sand and 2 of cement. I used half the amount of, 1 cement, 2 sand. So I only used half the amount of cement compared to sand. 2 times more sand. Well, it's the exact same comment, just swapped. If it's half in this direction, it's twice in the other. If this is half that, then that is twice this. Same statement. 1/3 of the mixture is cement. Well, that gets back to that Sheldon question. Instead of talking about just me versus you, it's talking about of the entire mixture. And yeah, 1/3 of the mixture is cement. Look at it. The whole mixture is 3 parts, and 1 part is cement. By the same way, if 1/3 is a mixture of cement, 2/3 of it is sand. So that page hopefully is just logical, that like, yep, all of them are saying the same thing. Okay, it depends whether I'm comparing you to you or you to the entire amount. There are 32 females and 18 males in a class, and that's just the consistency. Find the ratio of females to males. Well, they said females first, and then they said males, so it's clearly asking me F to M. It's 32 to 18. Yeah, that's all it's asking me. I want to check here, it's not saying ratio of females to the class, because I might have had to add the 2 numbers together, but no, it's not. It just says F to M, 32 to 18, simplest form. I'll call you 16 to 9, and we're done. Find the ratio of males to females in simplest form. What's the quickest answer to that? It's just the opposite direction. We've already simplified it. All they've done is said, no, I want M to F. Fine, 9 to 16. I'd already simplified. We can swap left and right. What percent of the class is male? So here is where it might be tempting to think, well, it's 9 out of 16, but it's not, is it? It said of the class. So the percent of the class, how many people in the class? Well, it's not 9 out of 32. I want to go back to my raw data. Okay, I don't want my simplified ratio. I mean, I could use it, but if I use my simplified ratio, I'd want to use 9 compared to the total, which is 16 plus 9 is 25. If I did that, I'd be happy. Or just use the original data. The original data said males is 18, and the total class is 32 plus 18 is 50. They're the same answer. 9 out of 25 from the ratio. Well, I admit, I'll just go for that. What percent of the class is male? 18 out of 50. That's a fraction. I admit that. How do you convert a fraction to a percent? This is one of the few things we need from Sem 1. In Sem 1, we said you got fractions and you got decimals and you got percents of the odd one out. And the only difference between them was you times by 100, either of them to get to a percent, or you divide by 100 to get it back. So 18 out of 50 times 100 will work out, it'll spit out 36%. Because what happened there? It became 36 on 100, which is literally 36 per century. There's the 36%. As long as we know, fraction times 100 will spit out my percent. Fantastic. Okay, we'll also get forced into other formats. And people get put off by this because we get too used to the simplified version. But there's times when we don't really want the simplified version. Here, in a survey of 1,028 URN students, 338 students stated that studying maths was their favourite way to spend the weekend. Real survey. 338 stated, so the ratio is 338 out of the 1,028. Not overly useful, but if we divide by 338, well, anything divided by itself will give you 1. Divide the other side by 338, that becomes something that might be used in a newspaper report. And I'd say, well, look, roughly 1 in 3 of the students preferred studying maths to doing anything else on the weekend. That's useful. So the ratio there was being forced. So we might get asked a question, express this ratio in a 1 to x format. What's x? Whatever. Remember, x is a variable. All a 1 to x format is saying is make the left 1. And what's the easiest way to turn a number into 1? Divide by itself. That's it. Okay, so this 1 to x or x to 1 format is just saying, this is saying force the left to be 1, this is saying force the right to be 1, and the other number is just whatever it happens to become. Okay? Hence, approximately 1 in every 3 students prefer to spend their weekend studying maths. And they preferred 8 AM lectures on Mondays. So expressed in the form 1 to x. What's the most common answer with this, despite the question? 2 to 7. It's not the answer. It's the answer in simplest form, but you know, we don't read questions all this. That's wasting time. But that will be there in multiple choice. Just beware of it. What's the true answer here? 1 to 3.5. Okay? Yeah, that's the ratio. Because all I was saying was just make the left 1. I don't care how ugly the other number is or isn't. Sorry, 3.5, you're fine. But the quickest way to do it was just divide by 4. 4 divided by 4 is a 1, and 14 divided by 4, I could have just calced it. 3.5, 3.5, 7 on 2. Don't care what way you want to answer that question. 350% if you want to be a smartass. It's all correct. Here it looks horrid, like, oh, yuck. Well, in calculator world, it's not. How do I turn 0.3 into 1? Divide by itself. So I don't care how horrible the number is, I've got a calculator, I'm just going to divide it by itself. So that gives me 1, and 1.4 divided by 0.3, well, 1.4 divided by 0.3 is 1.4 times 3 on tenths, which is 0.14 times 3, which is maybe 4.2? 4.6 repeated. I don't like that answer. Divided by 0.3. Oh, I've times it by 0.3, dildo. What was it? Nope. No need. Oh, you wouldn't be wrong, I should say. If you wrote 1 to 4.6 repeater, perfect. If you wrote 1 to 4.7 to 1 decimal place, you'd still be right. Doesn't matter. But note that because the 6 is followed by 6, it went up. Up, yeah. All good. Okay, expressed in the form x to 1. Just note that it's the right-hand side this time being forced to be a 1. All right, I'm just going to divide you by a 10. So I've decided the right becomes 1. 15 divided by 10 is 1.5. Similarly, if you want the right-hand side to become 1, I'm going to divide by a 0.06. Divide by a 0.06. And if we were doing it last semester, I would have said, well, that equals a 27 on 6, which is how many 3s are in that? But again, doesn't matter. The calculator's error, 4.5 to 1. Okay. 10-minute break. Please come back. So the next part of ratios is, so I've looked at simplifying ratios and 1 to x or x to 1, now using them. We haven't actually used them to find an answer yet. So there's two main ways that questions will get worded. Here's the first one. The ratio of the length to the width of your hand is approximately 2 to 1. For every 2 whatever's length, we've got only 1 width. Okay. If the width of Neil's hand is 9 centimetres, what's the approximate length? Now, I've used an overly simplistic question because if his width is 9, okay, he's going to have 18 long. But just to look at the way these things happen. So we look at length to width is a 2 to 1 ratio. So I'm just writing down what I was provided with, and then I got given some info. It said the width of Neil's hand is 9 centimetres. So width is 9 centimetres, that's when I can put the 9 there, and the question is just asking me, well, what goes here? Okay, so all of these questions, I write down the words, or the letters, L to W, whatever, the ratio it gave me one side, and it's saying find the other side. Now, there's two ways to find the other side. We can say, well, what happened to the 1 to get to a 9? Clearly got times by 9, so let's do the same to the other side, and it's 18. Okay, fairly straightforward. That's one way to do it. So I can look at between here and here. The other way I can do, which is just as good, is look between here and here. Look over, I think I put it at the side, or this also tells me that whatever the width is, the length is times 2. So if it's 2 to 1, something to 9, I can just say, well, I'd better times the right by 2 to get the left, better times the right by 2 to get the left. So it doesn't overly matter that you see both ways, but it's nice to see that, yeah, the ratio's, it's got two directions. I can say 1 became 2, so 9 became 18, or 1 became 9, so 2 became 18. Either way I go, I'm getting the right answer. Maybe even do one way and do the other way as a self-check. So let's check that with another example. Sally works as a commercial carpet shampooist. This one's already in the notes. She mixes shampoo with water, so I write down that. And the ratio 2 to 7, all right, keep the order. How much water will she mix with 60 mils of shampoo? So in this case, the 60 mils is on the shampoo side, the question mark's on the water side. Okay, it's exactly the same as before. But what's easier? Would you rather think 2 times something gives 7 or 2 times something gives 60? I'd rather do the 2 times something gives 60. 2 times 3.5 gives 7, I could use it, but I'd rather say 2 times what gives 60. And if I just couldn't spot it, you'll get that answer by getting the larger number divided by the smaller, because we're saying how many 2's are in 60. 60 divided by 2 is 30, hence 2 by 30 gets us to the 60. Do it to the right, 7 by 30 is 210. We've finished the answer, though I should say, how much water should you use? This semester, unlike last semester, units matter. Last semester was only in week 11 or something, and again I'm doing it, sorry, assuming that everyone was here last semester. What I should say is this semester, if there's units in the question, give me the answer. Like with tree, if you get an answer of 7 for the length of a side, 7 what? Doesn't mean anything. 7 centimetres, 7 millimetres, okay? Since we're applied, units matter. My answer here isn't 210. My answer is 210 of some units, and it was mils. So just make sure you give it the units back. So okay, hopefully that's a nice way. I don't know if I wrote the other way. I could have done it the other way. 2 times 3.5 gives 7. It just wasn't as nice. I'd rather do 2 times 30 gives 60. But what's 60 times 3.5? No, 210. Okay, so either direction. Let's do Elektra example. A string is cut in proportions of ratio 7 to 5. So it's doing a single, maybe it's like there. So it's got like a length of 7 there and 5 there. 7 what? I don't know. 5 what? I don't know. But for every 7 bits that's on the left, there's 5 bits on the right. So that's just, sometimes a sketch helps just to see what it's saying. But what's it saying? Okay, so we've got a longer piece and a shorter piece. So it's not shampoo and water or anything, it's just a longer piece and a shorter piece. So clearly, so I'm just doing longer to shorter. Clearly the 7's the longer and the 5's the shorter, because 7's bigger than 5. And it says the shorter piece is 45 centimetres long. So there's my question. I reckon if I lay it out that way, it's pretty easy to see that, well, again, I don't want to say 5 times what gives 7. Yuck. I could work it out. That's easier. 5 times what gives 45 by 9. I better times the 7 by 9 as well. And we're done already. Okay, the long bit, if the short bit's 45 centimetres, the long bit must be 63. Okay? Because the 5 got times by 9, the 7 got times by 9. Perfect. The real answer was 63 centimetres to 45 centimetres. And should be no surprise that if I look at the ratio of 63 to 45 and spot that they've got 9s in common, there are 7 9s there and 5 9s there. Yeah, of course it's the same ratio as the one we started with. That was the whole point. It was just bigger, okay, in the numbers. Let's check another one later in the workshop. So here's the other type of question. Hopefully I've got some mixed up. The other type of question is when you say, okay, that question just then was, look, we've got a ratio. If this side of the ratio is this, what's the other side? Okay, so you give me a ratio, you give me one side, and you've asked me to find the other. This question is saying, here's a ratio, split an entire thing into this ratio. So it's not giving me left or right, it's giving me the entire amount and saying, find left and right. Okay, so Sam and Chris invested in a takeaway shop in the ratio of 3 to 2. So Sam and Chris, 3 to 2, radio. Their business made a profit of $40,000. How much of the profit will they receive if the profit is shared in the same ratio as their investment? In other words, for every $3 Sam gets, Chris only gets $2 because that's the ratio they invested in, that's the ratio they'll get back. Like for every $30 Sam gets, Chris will get, for every $300, Chris will get $200, $3,000, $2,000. You can see, but I want the total to be $40,000, and I could still work it out, and I'll eventually get there, but let's do it in a way that's a bit smarter. I'm going to give Sam let's say three parcels of money. Okay, I'm going to put it into a parcel, same amount of money in each parcel. I'm going to give Chris 2 parcels of money. My question to you is, how much money should be in a parcel? Well, if they're all equal size, how many parcels do I need? To give him 3 and him 2, I need 5 parcels. If I get $40,000 and split it up into 5 parcels, how much is going to be in each parcel? $8,000. So what I'm claiming is, every parcel has got $8,000 in it. You'll get 3 lots of $8,000, which is $24,000, and you'll get 2 lots of $8,000, which is $16,000. Do they add up to $40,000? They do. Are they in the ratio 3 to 2? They are. Everything's good. Okay, so the concept here, whether I use the word parcels or bits or pieces, I don't remember what I did in the book. Let's have a look. I said parts. I called them parts. So I want to split it up into 5 parts. There was my 3 plus 2 is 5. My 40,000 divided by 5 parts was 8,000. Hence, every part was 8,000. 3 8,000s and 2 8,000s. Perfect. So I split in the ratio of 24,000 to 16,000. Let's do another. To make the colour orange, red and yellow. So to make the colour orange, big comma, red and yellow paint a mix. Okay, so it's only 2 things being mixed to make orange in the ratio of 4 to 3. So red is getting mixed with yellow in the ratio of 4 to 3. How much red paint is needed to make 140 mils of orange paint? So the total, again, this is type where it said, look, it might only be asking about red paint, but let's get the overall answer. We'll finish off with answer only red paint, but okay. There's 140 mils total we want. Out of 4 parts of red and 3 parts of yellow, I want it to make up to 140 mils. How many parts have I got? 7. 4 plus 3, there's 7 parts. Sure, 4 of them are red and 3 of them are yellow, but there's 7 parts. 140 mils divided by 7 is 20 mils. So it means every little part that I used of that 140 mils was 20. So 4 lots of the 20, that's 80 mils of the red stuff. 3 lots of 20, that's 60 mils of the yellow stuff. Always like to check, does it add up to what I had? 80 and 160 is 140, yeah. It's in the ratio 4 to 3. And then the specific answer to the question that was asked was how much red paint is needed. Therefore 80 mils, of red paint is needed. So the 60 I didn't have to write down, but All right, so that's the other, and they're quite clear, and I start them all the same way. I start them all, what words did you use? What ratio did you use? If it was the first type of question, it gave me another number, which I put there. But this type of question gives me a total, which I write down. So let's go into an Elektra example for this, and let's treat it exactly the same way. There are 80 people in a room with a ratio of men to women of 7 to 3. Men to women were the words. 7 to 3 was a ratio. It does not tell me how many men or women there are, so it's not the type from before. It's a total, 80 people. Okay, so there's 7 lots of men, 3 lots of women. What size is a lot, a part? It's the same thing. Overall, I've got 10 parts. So 7 plus 3 is 10, so it's 80 people split into 10 parts is 8 people per part. Okay, so there's 7 lots of 8 people make 56, 3 lots of 8 people make 24, and do they add up to 80? You bet they do. Exactly the same tactic. They sum to give me my parts, I divide the total by the number of parts, and I multiply each side by the size per part. Hopefully it's making sense. And then how many women? Okay, again, I should specifically answer the question. Therefore, hopefully I've said that before, that little triangle of dots just means therefore. Obviously you don't have to write it, but it's ingrained in the hand. Therefore, 56 women. And we don't, in this course, I know at school I was taught to give a full sentence answer. You'll get marks taken off if you give a full sentence answer, because you'll show me up and make me look bad. I don't care. Therefore, 56 women answers the question, doesn't it? Okay? But anyway, whatever just answers the question. Divide 84 into the ratio 2 to 5. Okay. Less of a word question, less applied. Could be $84. Who cares? It's just divide 84 into the ratio 2 to 5. For every 2 bits go to the left, 5 bits go to the right. How big's a bit? Well, 2 plus 5, it's 7. I'll use the term bits this time. Parts, sections, parcels. 2 plus 5 is 7 bits. 84 divided into 7 bits is 1 into that with 1 is 12 per bit. So again, it's 2 lots of 12 goes here. It's 5 lots of 12 is 60. So the answer I'm claiming, 84 divided in the ratio 2 to 5 is 24 to 60. They add up to 84, they're in the ratio 2 to 5. That's answered. I don't need to specify any part of it. Divide that in the ratio, 24 to 60 is my answer. All right, so really, these questions are unsimplifying a ratio. The questions earlier were, write this ratio in simplest form, and it wanted the answer 2 to 5. Now we're giving you 2 to 5 and saying, you know, how big are the actual ratios? We're undoing. So some random multi-choice ones. A batch of concrete uses 3 kilos of cement, 2 kilos of sand, and 1 kilo of rocks. How many kilos of cement are required to make 120 kilos of concrete? Now, know that concrete is the word for the combination of all of these things. So the individual things are, in Math 1900 once in undergrad, it wasn't deliberate, but I used this slide, and an accidental typo, I'd left the T off, went through and read it. So I used 3 kilos of semen, it was just one of those moments. Not to oh, don't give me that disgusted look. It's just a word. Oh, you meant with an E. Oh, you're disgusting. I was just talking about it's funny because there's no T on the end. Shocker. 3 kilos of cement, 2 kilos of sand, and 1 kilo of rocks. The semen question gives the answer where it's the D. That's horrendous. Okay, glad I brought it up. What we're doing, okay, there's 120 kilograms total, not 120 kilograms of cement, 120 kilograms of concrete, the name for the entire thing. How many parts are there? 3 plus 2 is 5 plus 1 is 6. There's 6 parts. There's 120 kilograms. 120 kilograms divided into 6 parts is 20 per part. So I could answer the whole question and say, well, it's 3 by 20, it's 2 by 20, and it's 1 by 20. There's the kilos I'm adding, and hopefully they'll add up to 120, and they do, 60, 40, 20, and the answer is the D. So that's the last you'll see of that slide. We're changing that for next year. Okay. But 3-parters, fine, there's 3 parts, add them up. The tactic was exactly the same. So that's ratio. Scale measurement is still related, but it's a backward step from ratio, as in a lot of them are a more complicated ratio, where it's got units in there that are different. Okay? A ratio and a scale still overlap. But anyway, let's have a look at it. Firstly, so a scale is used when we're looking at a map or a microscopic diagram, something that's been enlarged or reduced. Now, this is the first important thing. Until now in ratio, the order mattered relative to the words you used. If I put shampoo, then water, your shampoo, your water. But it made no difference if I swapped them. In scale measurement, that's locked in. The scale thing is on the left and the actual thing is on the right. In other words, I used to think of this as real life is on the right. Just the R in real life, the R in right. Whatever the measurement was in real life that you were given, maybe it said 20 centimetres on this map represents the 2 kilometres from here to Hunterside. So anyway, what's the real measurement that? The 2 kilometres. What's the scale measurement? The 20 centimetres. So it matters which goes on the left, which goes on the right. The actual measurement to the right and the scale, the pretend, the picture, the map goes on the left. Okay. I think of that as, that's a colon again, SCA. The first 3 letters of scale reminds me that I go SCA, scale, colon, actual. So I just always know the fake measurement on the left, real life on the right. Whatever helps. Units reminder, this is what I was suggesting this will do for this week, for the whole semester actually. If we're asking units, before we did mils, so it might be, you know, you could put milliliter in front of these, but this is the cheat sheet. Kilometres times 1,000 will give you metres. So whatever question, if you're asked to convert these kilometres to metres, if it's 2.3 kilometres, well, it's 2.3 times 1,000 metres. If you want to convert 0.6 of a metre to centimetres, just times it by 100. If you want to convert centimetres to millimetres, just divide it by, times it by 10. So that's my cheat sheet forward. My cheat sheet backward is the same with divide symbols. That'll do. That's this semester's units, whether it be metres, mils, whatever, grams, kilo to metre to centi to milli is always that. So if someone said, look, on this map I've got 2.6 kilometres and for whatever reason I want to convert it to centimetres, I just say if I want to go from kilometres to centimetres, I times by 1,000, then times by 100. In other words, that's times by 100,000. 5 zeros, 5 minutes. Or just chuck it in the calculator. 2.6 times 1,000 times 100, it will spit out my answer, which is 2, 1, 2, 3, 4, 5, which will give me the answer. So that cheat sheet, gold. Yes. So on a map of distance, 40 metres is represented by 1 centimetre. So a real life 40 metres is only 1 centimetre on the map. Find the scale as a ratio in its simplest form. Okay, so here's overlap. It's asking me for a ratio in its simplest form. So it might start with units, but it's saying get rid of them. Okay, first thing is, it's a scale measurement. Scaled result to the actual result. One of these is scaled, one is actual. The 1 centimetre has been scaled. That's not real life. The actual result was 40 metres represented by 1 centimetre. So 40 metres is in the real life. Okay, so that's the scale. There's nothing wrong with that as a scale, but it's asked for that scale to be transferred to being a ratio in simplest form. So I do want to convert. Again, I'm going to choose the small units. I could say 1 centimetre is 0.01 of a metre, but why go decimal and fractionary when we can just stay with whole numbers? I'd rather leave the small units alone, 1 centimetre. And I go to my resource sheet. My resource sheet says, how do I convert metres to centimetres? It says times by 100. So 40 times 100. And I've got the same units now, gone. Once I've got the same units, it's just a ratio of 1 to 4,000. Is that in its simplest form? You bet, I'm not getting 1 any smaller. They're whole numbers. Simplest form, I can't reduce it. The answer was just 1 to 4,000. For every 1 centimetre on the map, it represented 4,000 centimetres in real life, which is 40 metres. Okay, so as long as we've got our resource sheet, another one. In an enlarged diagram of a beetle, actual length of 15 millimetres is shown as 60 centimetres. So first I'm going, all right, we've got a unit change. Scales ratio in its simplest form, same question, but it's the other direction. That map was a 1 to 4,000. Scale to actual. The scaled thing, what's an actual length of 15 millimetres, so that goes on the right. The scaled thing was the diagram, enlarged, 60 centimetres. All right, let's pick on the smaller units and leave them alone. Doesn't make sense. I'm leaving them alone, I'm not picking on them. 15 millimetres can stay there. I look at my resource sheet and it says, how do I convert centimetres to millimetres? And it tells me to times by 10, because there's 10 millimetres in every centimetre. So it's 60, with another 0 on it, millimetres. So whereas it looked tempting to see, is this ratio going to be 4 to 1? No, it's 40 to 1. I can go the calc with this, or maybe you just divide by 5. If I divide, well, millimetres are gone. Divide by 5 will give me a 3. Divide by 5 will give me a 1 in there with a 120. Divide by 3 will give me a 40. That working wasn't essential. It's calculator world, but yeah, we had to convert the units, bring them down. So notice when it was the previous page, when it was a map, it was 1 to 4,000, because actual life was 4,000 times bigger than the left. When it's an enlargement here, 40 to 1, it's a great diagram. That's the beetle. It's 40 to 1, because actual life was 40 times smaller than the diagram. So you get the big number on the left when the scaled item is big. You get the big number on the right when the actual thing is big. So I admit, normally in life, I see this sort of scale where the one's on the left and the bigger number's on the right, because normally we're making things smaller. Okay? Well, in my life. Maps and so on. But when you're in biology and stuff, you're probably more on the other side. So which one's which? That's my check here. It's just left versus right. If it's a 1 centimetre long insect, drawn 20 centimetres long in the diagram, which is it? Scale to actual. Which one of these is saying it's the actual life is only a 1 centimetre long insect? It's B. So B is the one where it's like the scaled item is big, actual life is small. Okay? I actually find this, it's a fairly simple concept, but it does my head in a bit. I just come back to this. If that's S and that's A, the scaled thing is 20, the real thing is 1, it's 20 to 1. Okay. So, well, that's what I was saying. Look in the red. If red is small compared to the other side, well, that means the scaled thing is small. If the red is big, the scaled thing is large. Okay. Enough on that point, probably. So finding the length given the scale. So this is now like in ratio. Okay, we've talked about that's a scale measurement. Use it. The scale on a map of Australia is 1 to 10 million. So clearly, it's a map of Australia. It's got to be a pretty big scale. Determine the distance from Perth to Sydney if the distance on the map is 40 centimetres. So again, I'm going to write down scale to actual, because I know all these map things is always scale to actual. The scaled thing is 1, the actual thing is 10 million. Now, that doesn't have units, but it can do. If we're talking about 40 centimetres, I'm going to stick those units in. That means that 1 centimetre on the map is really the size of 10 million centimetres on the diagram. Okay, fair enough, but pretty confusing. 10 million centimetres, let's bring that down a bit. How do I convert centimetres to metres? My cheat sheet says divide it by 100. So if I lose 2 zeros off this number, all I've done is drop 2 zeros off it. I divided it by 100 because my cheat sheet said centimetres divided by 100 gives you metres. I'm going to do it again. Metres divided by 1,000 gives me kilometres. So 1 centimetre is 100. All of those statements are the same. 1 centimetre on my map, width of my finger, is worth 100 kilos in real life. But what was the question asking? Asking about 40 centimetres. Well, if 1 centimetre is that, surely I've just got to times by 40. And 100 times 40 is 4,000. There it is. The distance is 4,000 kilometres, roughly, from Sydney to Perth. So there was me manually going through it. Now, you could say, well, can't the calculator help me on this? Yeah, it can. And here's a nice tip, every scale question is 50-50. Whatever number you're given, you're either timesing it by this number or dividing it by this number. Now, hopefully in this case, if you're saying the distance from Perth to Sydney, is it 40 centimetres divided by 10 million? No. Or is it 40 centimetres times 10 million? Clearly it's times 10 million. So I could have just stuck that in the calculator and said, well, what's 40 times 10 million? My answer is 40 10 million. And I'd say I'm correct, but none of them are going to be the answer in multiple choice. And a non-multiple choice question would say, find the distance in kilometres, okay? So whereas, yes, all I had to do was times that 40 by the scale, there's my answer. Correct, but not done yet. As long as we just know the results sheet. That we say, well, that's how many centimetres. Take off 2 zeros to make it metres. Take off 3 zeros to make it kilometres. And okay, yeah, there it was, 4,000 kilometres. I wrote it out. You don't have to. You could use the calculator and do these conversions. But yeah, sometimes they will be as large as this. The flea in this diagram is a scaled length of 48 millimetres. Given the scale is 41, what's the length of the actual flea? All right, well, it's still scaled to actual. And it's still 40 to 1, all I've got to do is know, where does that go? The flea, it's a scale length of 48. Clearly it's on the left. So it's like one of the first ratio questions. I can either think 40 times what gives 48, bag's not doing it that way, or I could say the right times 40 gives the left, or in other words, 40 divided by 40 gives the right. Clearly, it's going to be divided by 40. As I said before, it's either going to be times by that number or divide by that number. If it's an enlargement, you times by it. If it's a reduction, you divide by it. Clearly, this actual flea is not 48 millimetres. It's a 40th of it. But in exactly the same way as we did the shampoo sort of question before, 40 to 1 means divide this side by 40 to get that. Well, I'm going to get 48 millimetres to divide by 40. So I go straight and just go 48 divided by 40. It gives me an answer in millimetres, which is 1.2 millimetres. What's the length of the actual flea? I don't need to do any conversions there. It's 1.2 millimetre. And also, we're an applied topic. Does that sound about right? Yeah, okay. If it says the flea is 1.2 kilometres long, doubt it. We're not that bad at writing questions, okay? There's going to be a self-checking, just is there common sense involved here? Yeah, you bet. So, pretty version, don't care. So if that flea is 14 centimetres long in the picture at a ratio of 1 to 12, how long's the actual flea? Again, is that too old for the reference? Does anyone know who flea is? Am I too old? Okay, it's still, mostly I'm too old, okay. Red Hot Chili Peppers? Okay. I'm too old. It's a ratio of 1 to 12. It's a 50-50 question. Either he is times 12 the height or divide by 12. He's not a tall man, but it's not divide 14 centimetres by 12. Yes, it's times. The scale is here, the actual is here, the scaled thing here is the diagram of 14. First I should write the 1 to 12. The scaled item is that. The actual is the whole question, and you can see from me laying it out like that, clearly actual life is times 12 compared to scaled. So all I've got to do is 14 times 12, which will get us to 168 centimetres, which is 1.68 scale measurement. It's not too shabby. So last one here, I think, just checking. Last two, okay. A 1 to 12 scale model, again, my tactics don't change. Scale to actual is 1 to 12. The model of the car is 25 centimetres long. That's not the real car, it's the scaled car. How long is the full-size car? 3 metres. Yep, because you can see that actual life is 12 times bigger. 12 times 25 centimetres is 300 centimetres, which is acceptable, but it could be, multiple choice, whatever. Or it could say how many metres long is the car. But clearly 300 centimetres, lose 2 zeros. No trap. Hopefully we're looking good. Last one then. An insect under a microscope. Okay, yep, they're the other way around. Doesn't really affect the way I approach the problem. It's 50 to 1. 10 centimetres long on a computer screen isn't the real life thing, it's the scale thing. 10 centimetres long compared to something. Here again, we can see that actual life is divided by 50. How do I get from left to right? I divide by 50. 10 centimetres divided by 50, well, that ends up 1/5 or 0.2 if you go to the calc. Doesn't matter whether dealing in fractions or decimals. It's 0.2 of a centimetre, okay? Times 10, 2 millimetres. That's all good. Successful start. Thanks for getting up early. Please do it again, like next week. Sorry? Oh, no. Oh, yeah. And